So I started working out on this and back in February, yeah, March. It's been like 1 month, but it's almost finished. Just need to be doing a little bit of tweaking and something, and it's going to be finishing soon. So it's the final design which I'm going to use, but we can improve anything, by the way. So this is not actually the final one. The final one looks different, like way more different, to be honest, because I initially thought that I will be making something which is kind of a bit different, but not like this. And it was initially I was initially thinking of making this this type, like something rests onto your cheeks over here, and there will be the screen and it will be reflecting directly back to the visor. I mean, this is the V HUD, so yeah, it will be reflecting back to the visor. But unfortunately I broke a lot of things because I made this thing with acrylic. Let me just tell you about the whole circuit here. So the main circuit includes a Arduino, which is placed over here. If you want to see, you can see it through here, or I could just show you through there. This is the Nano board, and it has a GPS module, a RTC module, which is not usable right now because I busted it actually while testing something. There's a DHT11 humidity and temperature module, and there's an accelerometer. So in case of a crash, let's just say we are moving in a fast pace and we just stop. Let me just simulate this. You see, it says crash detected, and it returns back. So yeah, there's an accelerometer module, so that detects the crash, and that's how it works. And about miscellaneous things, there are some touch sensors over here. I kept this for, I don't know, maybe for future purpose. I just like this place because this place is more convenient. You can press it straight up. There's a touch sensor on here which will show you the temperature. If I touch it, you can see the temperature. That's the temperature. And this touch sensor was initially actually planned to show you the date and time, but unfortunately the RTC module is busted, so maybe sometime later I'll fix it, or maybe in the future revisions I will fix it. That's that. And yeah, initially that was my idea, and on that idea I had another thing, that I will actually mount it in this way. My OLED display came with these small cases, so I initially planned to make this OLED mounting on my cheek over here. I mean, whenever you wear this helmet, there's gonna be a port, like, how can I say, an extension, just an extension, okay, just an extension coming out, sticking in your forward face or cheek, you could say, which is totally unhygienic. I can get it now, alright. And there's gonna be this module, or display module, and because not everyone's cheeks are same, so I eventually have to move this either forward or backward, which is really hard to do because I don't have any knowledge on those mechanical objects or hinges, if you say. So I just wanted to do this one thing, okay, and I stuck to this thing. So eventually what happened today was the final day. I'm actually iterating and doing things, and I had to bend it. You can see it, how much bend this is. Like, I have to heat it up and bend it every single day, slowly, because this is 2 millimeters of plexiglass, it's hard to bend. So everyday bending plus another thing. This was there. This is a groove you could see. This hole was there for the hinging of the whole mechanism. You can still see the hole over here. You can see it, right? This hole. That is where this one will go, and it will be mounting it, but it will be mounting on. So yeah, I changed it. And why did I change it? Because I was actually stuck. I didn't have any idea what to do and what else to do. But eventually what happened, at the very last moment when I was bending it, I bended it slowly, I bended it more, and it finally snapped. So I gave up, because this is my you could say third or fourth acrylic piece, which is, you could say, the cheekbone piece where the OLED to be mounted has been broken. So I was really frustrated. So I thought, I know how F-22 helmets work. There are those displays which are same, like mounted above over here, but those displays are different because those are really advanced things. Okay, really advanced things. So those displays are mounted over here, and they both project in crisscrossing pattern, you could say. Like both are in a crisscrossing way, so that's why they can project, otherwise they couldn't be. Yeah, so one of those projectors will project on this side and directly back to the retina. Another will project from this portion to this side back to retina. Believe me or not, it is very hard to do, because I know how hard optics is. I have worked on it, and it's not like I'm an optics expert, but doing this project was really fun. It was really a lot of hassle. Alright, let's just talk about the mounts of this thing. So if you can see, they're nuts. These are mounted with M2 pillars and some nuts, obviously. The front portion over here is mounted by two M2 screws. Underneath are M2 pillars, onto which these M2 screws are fastened together. And I initially planned to bolt this thing on. Like, this thing bolted on will be so much fucking awesome, because if I would have bolted this thing on, I could have just taken it out at any moment. But I have to initially destroy the helmet because I didn't have a bolt. Or you could say that I have a bolt, which is this bolt right there. I do have a bolt, and I have some bolts, but I don't have a drill. And even if I have a drill, that drill is broken. Like, that drill is so far gone, to be honest. You can see, let me tell you about the modules. This is the NEO GPS module, NEO 6M. This is the GPS antenna. I actually mounted it in such a, like, a tilt, like, how am I describe it? It's not straight, it's not tilted. It's tilted, but it's an angle forward. It will help in getting GPS fix more faster, to be honest. And yeah, so this is the new GPS module. In front of this empty place is the RTC module, which I actually broke. It was totally fine, working fine, but at last when I was checking, which means today, something bad happened. My multimeter was in current mode, and I accidentally tried to check a voltage across some data pins and things like that, and the RTC module actually busted in that way. So yeah, that's that. I can change it later on, so I will not. And the only reason I didn't change it, because if you see it, this RTC module is actually a structural. It's actually a structural importance, because it is supporting some part of our project. That's why I just kept it straight up. Yeah, all right. So in front of there, like this small one, you can see a small chip. That's an accelerometer. That is what detects the crashes. So the accelerometer. All right, hold on. I will tell about the accelerometer later on. Let me just tell you the rest of the things. This is the DHT11. I stripped off the initial pins because it was taking too much space, and you can see how little of a space there is. Like everything is just squeezed together. Okay, barely squeezed together. If you see, I had to replace an Arduino because the previous Arduino, which I actually ordered from Quartz Components, was kind of a sketchy Arduino, and it already contained a program which was writing at a very fast rate through serial, and it was impossible to re-upload any code. So yeah, I eventually have to order this from Robo. It worked. It was already soldered. The pins are soldered. If you can see around this battery portion, I don't know how to show you. Around this battery portion, around here, it's very tight. I mean, if you talk about tolerances, it's very tight. Alright, another Arduino here. This is the Arduino Pro Mini. So what I actually encountered was the GPS module and the accelerometer module cannot be interfaced together in a single Arduino. There was a problem, and that problem was maybe some kind of I2C communication interfaces. Maybe it was with my LCD, maybe with my RTC, I didn't know. But the safe thing to do was run the accelerometer in a separate Arduino, or you could say in a separate microcontroller. That is, in this case, the Arduino Pro Mini, which I had lying around, luckily. And yeah, it was lying around, so I used it to calculate the detection of acceleration and retardation, or sudden acceleration or retardation. So how it actually works, I will tell you. So basically what happens is when a sudden acceleration or a retardation is detected on any axis, X, Y or Z axis, it will send in a low signal through pin 9 or digital pin 9, and that low signal will trigger our Arduino Nano to know that a low signal has occurred. That means it has detected a crash. That is the main concept. That is the simple concept. It's not that much of a typical thing, but I just calculated the acceleration and retardation in a separate Arduino because to be safe. Alright, so about this plexiglass, I have to also heat up this plexiglass every single day for around 1 week and 4 to 5 days to make it this. But there are still complications because it is still not perfectly bent. As you can see, always the inner diameter is always smaller than the outer diameter of anything. So I didn't have any bigger plexiglass. I just have a 30 centimeters by 30 centimeters square plexiglass, and it didn't matter whatever, whichever side I cut in, it was 30 centimeters long. So yeah, I mounted the display eventually like this. What actually happens is there's this light coming down. Some partial light just reflects from this plexiglass. This is actually 1mm plexiglass. Yeah, from this 1mm plexiglass it reflects and goes on to the visor. But when it reflects and goes on to the visor, this image is still flipped. So that image comes back through the plexiglass directly to your eyes. Now this image is perfectly normal. So it's the same principle. You could say I have applied for my other demo project. Let me tell you about something else about this other specifications. Those are there are two batteries, 500 milliamps each, which combines 2000 milliamps, and this whole system draws around 250 milliamps of current. So this whole system, when fully charged, lasts for around 4 hours, which is not a great backup time, but it is okay, like totally okay, you know. Also the design is not too good, I know, man. When I wear this, I look like a fucking maniac. Like, look at this horn, it's like a fucking horn sticking out. It's weird, you know. It's weird, but it's okay, it's alright, it works for me. There's a charging module. This is a USB Type-C charging module, and man oh man, it gets really hot. It gets too damn hot, to be honest. I never thought that this charging module would be too damn hot. So how did I know, if you ask me? When I charged it, if you can see it, I mean, I am regretting because I initially thought that maybe there are some pins. So if I have some headers, these male headers. So if I could have just done those things, like I could have just soldered these and directly mounted on the PCB, it would have been better, but I don't have any space left. As you can see, it's fully full, like goddamn full. Maybe I could have any little bit of space on this PCB, on the, man, it's so hard to show you. On this, you can see the DHT PCB in front. There are some space, but it would have been not that much good, but yeah. So when I charge this, the temperature actually rises up so much that it actually melts the hot glue, and it comes out sometimes. Maybe I will find something else later on to actually fix. And yeah, that's that just wraps everything out, to be honest. Also, I need to mention something I forgot. You can see there is a pot, a trim pot, and a conductor, you know, and what do you call those? I forgot that. This inductor and a trim pot, that thing is a step up DC to DC voltage booster module. So that is important, to be honest, because the Arduino Nano actually has a specification of working voltage of around 7 volts to 12 volts. On the other hand, the Pro Mini or any other components which I have used is compatible with 5 volts or 3.3 volts. My batteries are 3.3 volts, not 5 volts. If they would have been 5 volts, they would be really big. Okay, I need compactness. So this boost module actually takes 3.7 volts from the battery and boosts this up to around 7.50 volts. I didn't overboost this thing because maybe if something goes wrong, if the load increases, it will affect the Arduino Nano. So I just didn't do a over voltage or kind of thing. Yeah, it just boosts on maximum of up to 24 or 50 volts, I guess. Yeah. And let me show you about the Arduino which was faulty. This Arduino, you can see it, how genuine it looks, but it never runs good because there's an already an code running. It was fresh Arduino, but it came with a code, and you know how it is. That's how it is. Okay, so that wraps it up. Hey, this is the behind clip. Let me show you. Can you see it? There is a projection on the screen. I mean, this is actually opted for, you know. There you go. Yeah. That's almost visible. This is actually tuned for human eye perception, but still, my hand's so wobbly. You see this? This is the projection. If I put the visor up, you will not see it anymore. That's the beauty. Yay! I have actually kind of made it almost, you could say. Let me just a bit. It's not actually this one, it's actually this lower one. See this lower one, GPS speed, it's showing in a perfect way. You can see the lower one, but through human eye perception you can see the lower one, and the lower one is the main one, not the upper one. Yeah, I know the upper one is bright, but the lower one isn't actually. Hold on, maybe I can. Yeah, it's barely visible. Yeah, you can see it, I guess. It's really barely visible, but it's more larger than the upper one. See that, like 5.76 showing. Oh, there you go, there 1.14. That's the actual one, like this one. Big enough. It has grown up ever since. So it looks like this after a while. This. Maybe I could have been chosen a good helmet, to be honest, because this strap is bad. Like, it hurts my Adam's apple, you could say, on my neck, my throat, whatever. So yeah, I can see. Let me just go back a bit and let me just show you. So I can see around here, and the space is around, like, the total space I can see is this much, which actually interprets to this much. I can see that much, okay. And I'm planning to do this in a special way. Like, if I upgrade it, I'm going to be actually placing a one-way mirror reflective, those panel stickers or films that comes in, so I can use it to reflect as much as I can, or as much as they allow me to, because it depends on the film. Right, so the one-way film allows me to see through, but it reflects a lot, which is important. If it reflects a lot, I can at least see through, but the image which I am actually going to be seeing is bright enough to be seeing in this lighting condition. I mean, I cannot see in this lighting condition at all. Like, if I put down the visor, yes, I can see, but it's very, very dim, which is not really ideal, to be honest. So to see something very bright, I have to use the film, to be honest. Or yeah, there was this another option which I told you about. If I have mounted it, it probably looked like this. Just simulate it, maybe. Yeah, like this. There will be my display, which would have been reflecting over here. This place. Now the problem with that was that I could have designed the whole setup to be working in that configuration, but there was a problem, and that problem was that I have to flip each and every letter from right to left, which means if I flip the display, it's going to be flipping, so it's going to be displaying from right to left. So I have to display from actual right to left of the display, which is going to be flipping in this way, to actually right from left to right. I mean, it is just like a very complex thing. I was on my way to design a library too, but what kind of library? If you ask me, some custom fonts and some extra things like special, not special, you could say, like modifying the Adafruit SSD 1306 library to actually display something from right to left and sequentially in reverse order. I got the fonts, but I have to upscale or downscale that thing, so these are hard to do. That's why it's not much preferable to do something else than these. And yeah, this was okay, but the only downside is that you get a screen which is very dim. It is too dim to be seeing this lighting condition, which is the ideal lighting condition if you say on the road. But having too much dimness, it'll never work that much good. So yeah, I ditched the plan. And yeah, that's that about the ABWI V HUD or Visor HUD.